Okay, so this video is to do the introduction to vocabulary. I'm going to kind of go quickly through some of it since you have the notes that have the definitions written, but there's just a few things that I wanted to give a verbal explanation to. So the main idea of this course is that we will be collecting data from a small part of a group so that we can learn something about the large group, which is the goal of any statistics that you want to find. So we have data, which is just collections of observations. So measurements, genders, survey responses, grades, any kind of observation is your data. This is the actual definition of statistics. So it is a science of planning studies and experiments, obtaining data, organizing, summarizing, presenting, analyzing, interpreting, and drawing conclusions based on the data. So that's what we will be doing in this course. So a population is just the complete collection of all individuals or the entire group or the whole group. Most of the time you'll see the word all, but entire and whole are also keywords to indicate population. Census is just a collection of data from every member of a population. Sample is a sub-collection of members selected from a population. So you have two numerical measurements. One goes with population. That's called a parameter. So you can remember that P's go together. So for instance, if you have the average atomic weight of all elements in the periodic table is 134.355 unified atomic mass units, that is a parameter, that number 134.355, because you're looking at all the elements. So that's the population. So and then the S's also go together. So a statistic is a numerical measurement describing a characteristic of a sample. So if he randomly selects 35 movies, he's not selecting all movies, just 35, so that's a sample. So the average gross from ticket sales was 123.7, so that would be a statistic. So you can kind of remember P's go together, population and parameter, and S's go together, statistic and sample. So if you want to identify certain parts of a problem, this farmer wants to learn about his green bean crop, so he sampled 200 plants and measured the weight of the green beans on the plant. So the sample would be the 200 green bean plants that he selected, and then the population would be all of the green bean plants in his crop, or the entire crop, or the whole crop. Like I said, typically you'll see all, but entire and whole are also keywords that indicate population. For the second example, you have a survey of 342 teenagers at a local high school was taken, and it was found that 82% owned a cell phone. So the population would be all of the teenagers at the local high school. The sample would be the 342 teenagers that they surveyed. And so that means since the 82% is from that 342 that they surveyed, that goes with the sample, which is a statistic. And then for percentages, if you want to know exactly how many surveyed teenagers own a cell phone, that's basically just asking what is 82% of 342. So if you multiply, you'll come out with 280.44. And we can't really have 0.44 of a person, so you can just round to say 280 own a cell phone. So we have a few types of data. The two that we're going to look at will be quantitative or numerical data, which consists of numbers representing counts or measures. So like weights, ages, anything that represents a count or a measurement is quantitative. And then qualitative or categorical, you can use either word. I think usually I'll say categorical, consists of names or labels representing categories. So genders, and then shirt numbers, even though shirt numbers on jerseys are numbers, they're just substitute for names, so it's still just a category. So here are 9 examples where you want to identify the data as either quantitative or categorical. So gender is categorical, it's category. Temperature is a measurement, so that would be quantitative. Eye color is a category, so that will be categorical. Zip code, again, zip codes are numbers, but they're just they're not a measurement, or they don't count. They're just locations, so that is categorical. Average salary of a faculty member at the college I work at, that is quantitative. Number of days during the past week that a college student has worked, that would also be quantitative. Social Security number, again, it's numbers, but it just represents a person, so it's categorical. Heights of males will be quantitative because height is a measurement. And the number of times a 2 is observed after rolling a die 15 times is quantitative because you're counting how many times a 2 occurs. So there are the answers for those 9. So if you have quantitative data, you can break it down into discrete and continuous types. Discrete data, you can read the definition. It's a countable number. Basically, I remember it by saying discrete, you cannot have any decimals. So the number of eggs that a hen lays, the hen will lay an egg or it doesn't lay an egg. There can't be like 1.5 eggs. A car randomly selected at a traffic safety checkpoint, and the car has 6 cylinders. You can't have half of a cylinder. So if it's whole numbers, then it's discrete data versus continuous data. So continuous data can be decimals. So the amount of milk that a cow produces, it may produce 2 gallons per day. It may do 2.3 gallons per day or 2.345, and you can keep going with the decimals. Same thing for the volume of cola in a can of Coke. It can have 12 ounces, or it could have 12.1, 12.2, 12.1267 or something. So if you can have decimals, it's continuous. So another way to classify data is the level of measurement. The nominal level is the lowest level. It is data that consists of names, labels, or categories only, and it cannot be arranged in an ordering scheme, such as low to high. So if it's just categories and it can't be arranged anyway, low to high or high to low, it's nominal. So for example, for these would be survey responses of yes, no, undecided. The numbers on the back of a basketball jersey, you can arrange those, but it doesn't really tell you anything. Just because a player wears number 2 doesn't mean they're better than the player with number 14. So that's nominal level. Social Security number, same thing. You can arrange them, but it doesn't tell you anything. And then marital status is just categories. Ordinal level is still categorical data, but you can actually arrange them from like low to high. So A, B, C, D, or F in a course, everybody knows an A is better than a B, is better than a C, is better than a D, which is better than an F. So those are arranged, even though they're categories, they're arranged in an order, high, medium, low, and first, second, or third place. So those are all categories, but they are arranged and have meaning when you arrange them. The other 2 levels go with quantitative data, or quantitative data, which is interval level. And you can read the definition, but the way I remember interval level is, does it start out at 0, or basically can it have negatives? If it can have negatives, then it's interval. The only trick to remembering interval is that years are always interval, even though we don't have negative years. You can think about it like BC being negatives and AD being positives. The other reason is the measure of years did not start at 0. So you just kind of have to remember that years are interval. Sea level, you can go below sea level, so that would be your negatives. And the temperature outside can go into the negatives, so all those are intervals, interval level. The ratio level is the additional property that there is a 0 starting point. So basically, ratio, you cannot have any negatives, so you can't think about it as negative on a number line. So prices of college textbooks, everybody wishes that they would pay you for a college textbook, but they do not. So it's either going to cost you nothing or it will cost you something positive. Length of a piece of wood, you can't have a negative length of a piece of wood. Ages, you can't have a negative age, and the score on an exam also can't be negative. You can have a 0 or you would have something positive. So anything that can't be negative is ratio. So here's the quick summary. So nominal is just categories only. Ordinal is categories with some order, so you can arrange them low to high, and that makes sense to do. Interval is the ones that it doesn't start out at 0. You can think about it as having negatives, and ratios do start out at 0, so you can think about those. You cannot have any negatives. So the first thing you can do if you're asked to determine the level of measurement, if you first decide if it's categorical or quantitative, then you can eliminate 2, because categorical data will always be nominal or ordinal. Quantitative data will always be interval or ratio. So usually it's easier to decide categorical and quantitative, and then you can eliminate 2 levels, and then you just have 2 more to pick from. So if we want to identify the level of measurements, heights of basketball players, for your heights, those are measurements which are quantitative, so you know it has to be interval or ratio. You can't have any negative heights, so that one will be ratio. Morning temperatures, I live in the Tri-Cities, so at the Tri-Cities airport last week. Again, that's a measurement, so it's quantitative. Temperatures can be negative, so that would be interval. Zip codes are categorical, and so you know it has to be nominal or ordinal. You can arrange zip codes, but it doesn't tell you anything since they're just locations, so one location's not better than the other based off the zip code, so that would just be the nominal level. Distances traveled by students over Labor Day weekend. Distance traveled is quantitative, and you can't travel a negative distance. You either stay home or you go somewhere, so those would be ratio. The actual contents of chips in a bag, that's a measurement, so that would be quantitative, so you know it has to be interval or ratio. Again, you can't have negative amount of chips in a bag. It's either it's empty or there's some in there, so that will be ratio. Ratings of above average, average, or below average for new movies. Those are categories. However, they are arranged in an order that makes sense, because if you're looking at the ratings and you're going to pick the movie, you'll probably pick one that was rated above average over one that was rated below average. So that one is a categorical, but it is ordinal because it's ordered. And the years in which this is the stats course that I teach full-time at my college, it's called Math 1530. So I put it on here because the years in which those stats students were born, well, obviously none of my students were born in the ADs, but you have to always just remember years, regardless of what it's referring to. Years is always interval, because years do not start out at 0. So there's those answers. And here's a helpful link. If you would like to visit this website, you can go read it. It also has explanations and different examples than what I gave for the levels of measurement. So usually what we have to do is collect data, and we collect data from 2 distinct sources. So we have observational studies and experiments. So an observational study just means you're going to observe and measure specific characteristics. You're not going to attempt to modify anything being studied. So if you just survey 1,000 adults by telephone and ask them, and 22% of them reported that they smoke, you're not trying to get them to quit or change cigarette brands or anything. You're just asking if they smoke or not, so that's an observation. Versus an experiment, you apply treatment and observe its effects. So if you try a new medical treatment among a group of people, then that's an experiment because you are attempting to modify. You have types of sampling. We're going to have 5 types. There's actually 6 listed on the notes, but the ones that are starred are the ones we're going to focus on. So a random sample just means everyone has an equal chance of being selected. Systematic sample means you start at some point and select every 10th or 11th or 12th or whatever number element in the population. Convenience, you use, convenience, you use results that are easy to get. Stratified, you subdivide the population at least two different subgroups that share the same characteristics, then draw from a sample from each subgroup. And cluster, you divide the population into sections, then randomly select some of the clusters and then choose all of those. So usually stratified and cluster are the two that are confusing. For this first one here, he selects every 10th bulb starting with the 7th until he has 250. That means that it would be systematic. In order to determine the average height of 10th graders, a researcher obtains a list from all high schools. She randomly selects 5 of the schools and takes a measurement of all graders. So that one is cluster because she has a list of all of them. She selects 5 of them, so you can think about the schools as being the cluster. And then she takes all the measurements from those 10th graders. So that one is cluster. In an effort to identify whether an advertising campaign was successful, they conduct a nationwide poll of randomly selecting individuals from a list of known users. That one will be random. It tells you in the problem that they randomly select them, so every user of the product on the list has the same chance of being chosen. If you're asked to call in regarding your opinion on the Anchorman, that's convenience. It's something that's easy to obtain. Everybody can call in and say yes, they like the new Anchorman, or no, they do not. And then if you divide the student population into 3 classes, 6th graders, 7th graders, and 8th graders, and then take a random sample from each class regarding the first day of school, that one is stratified because you subdivide and then you take a sample of each subdivision. So like I said, the two that are most confused are stratified and cluster. So stratified means you subdivide and then take a sample of each. Cluster is when you pick clusters and then do all in the clusters that you were in. So I just wanted to quickly give some verbal explanations for some of these vocabulary, because some of them are confusing if you just read the definitions. And apparently, my husband's sitting here, he said my students weren't born in AD, so I meant to say on that way back here, the years in which students were born somewhere, if I can find it again. The years, they weren't born in BC is what I meant to say. So all the students were born in the past years, but still years didn't start out at 0, so it's interval level. So it's kind of hard to sit here and talk to just an empty room. But if you have questions, you can let me know, and everything is typed out on the notes as well. But like I said, I just wanted to give you a verbal explanation for some of the terms.